Hello, welcome to Conceptual Physics. My name is Gene Peer. This is my 20th year of teaching for Chieftain Institute. It's my 45th year of teaching altogether. So I've been at this quite a while. I've been teaching physics specifically for, I hadn't thought about it, probably have been teaching physics for about 30 or so of those 45 years. What is physics? I often get that question. Physics is a science. Some folks think it's a math. Well, it can be a math, I guess, but it's mostly science. Physics is the foundational science. It's everything is based on physics. I was just talking to a friend just recently as we were moving furniture around or something, and we were talking about using physics to move heavy items. And he, having been one of my students long ago, said to me, everything is physics. And that is true. For instance, biology is based on chemistry. But what's chemistry based on? Chemistry is based on physics. Everything is based on physics. A couple examples of what we consider. One of my favorite objects in the world is this paperweight filled with sand or something. I don't know what's inside there, but it's fairly heavy. And physics answers questions such as, if I toss the bag up, if I know my launch speed, how high will it rise? How long will it take to get to the top of the path? How long will it take to get back to the bottom? How long will it be in the air altogether, known as hang time? What is the acceleration rate on the way up and on the way down? Or if I simply drop it, how long will it take it to hit the floor? How far will it travel if it falls for, say, 2 seconds? We'll be answering questions like that. We'll also answer questions such as this. I love this little thing here. This is called a ballistics cart, and I hope it works for me. It doesn't always work properly because the table has to be perfectly level, but I put a ball down in here. It's spring-loaded. If I pull this pin out, hopefully the ball will fall back into... Well, that wasn't very impressive. It wasn't very high. See if I can do it higher. Oh, good shot. All right, so the question is this. If I do the same thing and load it, and then roll it across the table, and as it rolls across the table, if I yank the pin out, where will the ball land? Will the ball land behind the cart? Will the ball land perhaps in front of the cart? Or could the ball land in the cup? Where will it land if I pull the pin? No, I'm not about to do that for you. You have to wait until class to find out what happens. That's physics. In my humble opinion, physics is the best science. In fact, it's not just the best science. With the possible exception of math, it's the best subject of all, and it's a lot of fun. See, there are, the book that we use is Conceptual Physics by Paul Hewitt. If you go shopping for this book, you'll find that there are a number of different editions. This happens to be the 9th edition. We use the 9th edition. Do not get the 10th or the 11th or the 12th because you'll be confused all year because we'll be on different page numbers. Although all the books are pretty close to being the same. We use the 9th edition. Why are we stuck back in the 9th edition? Because I've been using the 9th edition from the very beginning for about 20 years, and all of my notes are in the 9th edition. All of my tests that I've written are based on the 9th edition. And there's nothing wrong with the 9th edition. In fact, a little side note, over the years, not over the years, years ago, about, maybe 15, 20 years ago, I accidentally started corresponding with the author. And that's a long story. How do you accidentally correspond with an author? Well, I managed to do it. And I accidentally criticized a couple of points in the book. Well, he got hold of that, and he responded to me and made some changes, and then asked me for more input, and I gave more input, and On and on we went, and eventually he told me he was going to put my name in the credits of the book. Years passed, and, well, he forgot. I reminded him a number of years later, like maybe 8, 9 years later, I reminded him, hey, remember me? And he finally did put my name in the credits of the book. So the newer editions have my name in the credits. How about that? I was so honored. This book is a college text that's used by about 85% of all the colleges and universities in this country. It's a very popular text. But do not let the fact that it's a college text scare you. This is conceptual physics, which simply put means that it's, well, physics without the math. Some folks, I hear that, oh no, I wanted real physics, physics without math. Okay, let me put it like this. Folks who have been through this book with me have been phenomenally successful in their college classes. They frequently end up being the leaders in their college classes. Everybody else is confused. Folks who have been through this book with me are on top of it because they understand the underlying concepts, and then when they take the math-based physics in college, they're ready to add the math to it. They've already got the basics. I had a student one time long ago who came back to me after his first semester at University of Maryland, and with his mother standing beside him, so I know he was being honest with me, he told me that he was accused of cheating on his first physics test at University of Maryland because his score was too high. He had to be interviewed by the professor to verify that he actually did know what he was doing. And he had done a particular problem doing a technique that the professor had never seen before. And they asked him, where did you learn that? Well, he didn't mention my name. He just said, in high school. But anyway, so I didn't get much credit for that one. But this book is incredibly successful. We have graduates. I have one graduate who, last I heard, was a nuclear engineer on a nuclear submarine. I have graduates who have gone into the Air Force Academy. I have graduates who are science teachers, architect, engineer. I have a graduate who is a scientist at NIST. A number of folks have told me that they were never really interested in physics before until going through this book with me. When I say go through the book, we'll only cover about half of the book. Yet, obviously, it's very effective. What are the keys to doing well in this class? First of all, number one, pay attention to class. Now, I would claim that paying attention to class is very, very difficult to not do because it is just plain fun. And I've been doing this long enough that I've developed, I think I've developed a somewhat entertaining style. So it's pretty hard to not pay attention, but that's key. The second thing is read the book. Far too many students never bother reading the book. And that reason, because Paul Hewitt says it better than I can. And if you don't read the book, you're shooting yourself in the foot. It's easy reading. Again, it's conceptual physics. And Paul Hewitt is he's at least nationally famous, if not world famous author. His writing style is very easy to read. So read the book. The chapters are short, not a big deal. They're kind of fun to read. No, they're kind of fun. They're really fun to read. The third key to success is the review assignments. It's easy because I grade the review assignments on completion, not on accuracy. It is easy to kind of blow off the assignment and just give quick, thoughtless answers and just move on. But seriously, if you don't take the assignment seriously, if you're not determined to understand every question and get every answer as accurate as you possibly can, if you are not determined to get it done right, well, again, you'll be shooting yourself in the foot. Those who take the review assignments seriously are the ones who most often do the best. Anything else I need to mention? Grading system. The course is 67% tests and 33% homework completion. I assume that I will continue a tradition that goes way back now of ending the year with our famous bridge building contest. And we'll have much more to say about that in the spring. In the meantime, what do you need? All you need is your book, 9th edition, the orange one. You need a notebook, something to write on, write with, and you need your brain, an inquisitive mind, and brace yourself to be challenged. Challenged in that you will find as the year progresses that there are many things you believe about the physical world around us that will turn out to be totally false. And that's part of what makes it fun. To discover things that you thought you understood, and in reality, you were so far off it's ridiculous. And to get those things straightened out and to figure out why they're true. It's a lot of fun. And all in the context of recognizing that God is the creator of all things. I like, in fact, I have it, you can't see it, of course, but over my windows here I have this gigantic sign I inherited from a previous teacher. It was a quote by Galileo. Mathematics is the language with which God has written the universe. And that language was used to write, well, physics, the laws of the universe. It's cool stuff. It's a lot of fun. It's not as complicated as you might think. Do not let the word physics scare you. And that's it, and I'll be looking forward to seeing you all on the first day of class. So until then, enjoy the brief rest of your summer, and thank you for watching. Goodbye. Now I have to go around and turn off the recording.